Hi all, this is test number 3, so that you can test your math skills in chemistry. We've got 5 questions to have a look at, and again I'm going to highlight things that you should be looking out for that the exam board are going to try and catch you out on. First of all, this first question is about working out moles. If you do the foundation paper, you don't need to worry about this sort of question, as you will not be asked to do this. So the number of moles of a substance, its mass in grams and its relative formula mass are linked by the following formula. Number of moles equals mass divided by relative formula mass, and that's what that MR stands for. Now the first thing I always do is put this into a triangle. So where I've got my divide line there, the object that's above the divide line goes above the divide line in my triangle. So the mass goes over to there, and then number of moles and relative formula mass will go onto the bottom with a multiply in between. Now the question says the mass of a compound is calculated by adding up the atomic mass of the atoms in that compound. Calculate the number of moles in 75 grams of magnesium oxide. So I need the moles, so I've put a question mark there because that's the one I need. I've been given the mass, which is 75 grams, and I've got to try and calculate my relative formula mass. Little clue, if ever you see this where they are giving you the masses of the different chemicals, it means you're usually going to have to do something with them. So I've got to work out the relative formula mass of magnesium oxide. I've got 1 magnesium, I've got 1 oxygen, 24 add 16 equals 40. So I take my calculation from here. I want the moles, so I cover that over. Mass divided by relative formula mass, and I'll write that down there. Always show the calculation you're going to use. I've shown how I've worked out my relative formula mass. I now put that into a calculation. 75 divided by 40 equals 1.875. However, and this is the bit lots of students miss, it's this last bit here. Give your answer to 2 significant figures. So I've written the full answer there just in case I convert it incorrectly into 2 significant figures, and I've got 1.9. So at least I would pick up marks for showing my working out. Okay, question number 2. Again, if you're foundation, you don't need to do this one. This one is looking at 4 moles of a mass have a mass of 0.176 kilograms. Watch out for that, because we always like to work this out in grams, and this is in kilograms. So what you can do is if you multiply that number by 1,000, you'll get it into grams. Or you could think about, if I've got a 1 kilogram cake, that's 1,000 grams, and 0.176 kilograms of it is what I'm looking for, that is 176 grams in that kilogram cake. What is the relative formula mass of the gas? So again, this time, I want this part. So I've put it into a triangle. And I put my finger over there, so I've got mass divided by moles. I've written down my calculation. My mass is 176 because I've just converted it into grams, divided by 4 because there's 4 moles equals 44. No units for this because it's just the mass of the atom. Okay, so question 3. Everyone should be able to do this, foundation and higher. The table below shows the yearly carbon dioxide emissions for a power plant. Calculate the percentage increase in carbon dioxide emissions between 2015 and 2017. So I can completely ignore 2016 because I don't need that data at all. What I do need to do is see how much it's increased from there to there. So first of all, I take my biggest number, take away my smallest number, and then I divide it by my original value because I need to know how much it's increased. So that divided by that times 100 equals 4.5%. This next question then is looking at a table of data. A table below shows the composition of the waste recycled by a waste collection facility in 2017, and I've got different materials there, and I've got the percentage of each waste. I need to draw a bar chart of this data on the axis below. First of all, I've been given the actual axis labels, so I don't have to worry about that. At least I know which way round it is. If I don't know, always remember the one on the left is the independent variable, and that always goes on the x-axis, and the one on the right is always the dependent variable, and that will always go on the y-axis. Now, because this is a bar chart, I do tend to make sure the bars are not touching, because that's usually a histogram. And for this also, I need to look at the range. So it runs from 4 all the way up to the biggest number, which is 38. So rules for graphs. You should use more than half of the graph paper when you are plotting your axis. Okay, now this one is easy at the bottom because it's just indiscrete categories. So glass, paper, plastic, metal and other. Whereas this, I've got to get from 4 to 38, so I'm going to go up to about 50. 10, 20, 30, 40, 50. And then I make sure I do a straight line. I put a dot on my paper so I know exactly where it is, a dot there, and then I join it all up. And I do that to make sure I get my 3 marks. I'll get 1 for plotting that axis, I'll get 1 for actually plotting these at the correct places, and then another one for making sure the bars are all the same width. The last part says the waste collection facility recycled 1.68 times 10 to the power of 6 kilograms of waste in 2017. Use the information in the table, calculate the mass in kilograms of glass, just glass, recycled by the facility. So if I look at my table here, I've got 26% has been recycled. I've got to work out 26% of this total number here. So 1.68 times 10 to the power of 6 times, and I've already converted it to 0.26. You can do the 26 divided by 100, you'll get that number, and the answer is 436,800. Okay, thank you very much.